Welcome everybody. Welcome to the Python course. In this part, we will cover the module 4, that is list and tuples. This module is been divided into two parts. In the first part, we'll cover the topic of list. In the next part, we'll cover the topic of tuples. In the list, we will look upon introduction to list, how to create a list, what is list indexing, list slicing. We could see the various operations that could be performed on list. Then we will see how list behave as a stack. Then we'll go for the nested list as mutable, why it is mutable, shallow copying and deep copying, right? So this topic we'll cover in this module. So let's get started. Let me open my Anaconda navigator. Okay, so let's get down to Jupyter notebooks. Okay, now let's get into the directory. And let's create a new Python Jupyter notebook. So I'll name this as module 4 underscore lists. Okay. Okay. So let's start. What is a list? So list is a basically an ordered collection of items, right? So items in a list could be of any Python data type. That could be a string, that could be a number, or it could be a list also. It could be a tuple and dictionary, right? So list, we could say it is similar to arrays in C, Java or C++. But what is the difference between an array and a list? That is, array similar to C, Java or C++ and Python list. So basic difference between list and an array is that array will try to hold the elements that of similar data type. For example, we could have an array of numbers, array of strings, right? Array of boolean values. So these are of similar data type. But in list, we could have any data type, any Python data type. That could be a string also, that could be a number also, that could be a tuple also, or dictionary also, right? So for example, I'll give you a practical example. List is basically a bag, right? So it is a bag in which you is a shopping bag basically. You take this shopping bag out for shopping, right? In this shopping bag, you could get your grocery items also, right? You could get your fruits also, that is of another data type. That could have vegetables also, right? So it consists of a mixed data type. That is basically a list, okay, right? But in the arrays, you have to separate out the data types, right? You could hold the similar data types. For example, in a bag, you could only hold frozen food. You cannot hold other than foods other than frozen food. So that is an array which consists of a data type which is similar, right? So this is the basic difference between list and an array, right? Now here in the screen you could see that list could be represented by a square bracket, right? So colors is a list is of type list which consists of some data type, and the data type which it holds true is of string, right? Let us try it practically. For example, I have my bag, right? So this is my empty bag. So I run this and I try to find the type of my bag. So this is a list. So this is a inbuilt data type which is provided by the Python. So this is empty. Right now it does not hold anything, right? Or we call it as an empty list. Now what I'll do is I fill this bag with some elements. I would have a string, I could have a integer, right? I could have a floating point value also, right? I could have a boolean value also. So this is my list which consists of a mixed data type, right? I could have a list inside the list also, that could be also be there. So first try this and then I'll print this. So now in the list or in the bag we have some elements which are of different data types. Ram is a string, 1 is an integer, 13.6 is a floating point value, true is a boolean value, right? In this part also we could have list inside a list. So I could say Ramesh comma Suresh. So this is list inside the list, right? This could also hold true. Okay. Now in the list every element is represented by an index value. In this part list we have a list colors, right? The name of the list is colors, and the red element is present at the 0th index, blue is present at the first index, and green is present at the second index. So this is how indexing works in list, right? Okay. Now how we can access the elements? We can access the elements of a list by using its index value. By default the index starts from 0 and we cannot change the index value, right? So we cannot have the index to some user defined value that we cannot change in a list. So that itself is represented as 0, 1, 2 as a integer value, right? For example, in this problem or in this my bag, I wanted to access each and every element. So how I can do it? My bag 0, at the 0th position Ram is present. Similarly, at the first position 1 is present, second 13.6, third true, and at the 4th position we have a list, and inside this list we have two elements, that is Ramesh and Suresh, right? Now we could represent or we could access Ramesh by putting another notation, that is 0. It is basically a list, right? From here to here we have accessed the list. Either we could copy this list into another list, that is my small bag equal to whatever elements we have in this bag, that is Ramesh and Suresh, we have copied into my small bag. After copying into my small bag, I could access in a similar manner as we have accessed the my bag. At the 0th position Ramesh is present, and if you wanted to access my bag, small bag, full bag, so Ramesh and Suresh are two elements which are present in my small bag. And if I wanted to access the first element, that would be Suresh. So this is how we can access the elements inside our list. So list, basically we need to remember two things. List, we could have mixed data types, mixed Python data types. and it is an ordered collection of items. And the major difference between array and a list is that array could hold the elements which are of similar data type, but in the list we could have a mixed data type, and we could have a list inside a list, list inside a dictionary, or list inside a tuple also. That we gonna see in the upcoming lectures. Now we have seen how to index a list. So index value starts from 0, right? Now this was the positive index starting from 0. We have the negative index which starts from the last element, which is present inside our list, that starts from -1. Positive index starts from 0, negative index starts from -1, and from the end element which is present at the end, right? The colors is a list, it consists of 3 elements, and I wanted to access green, that I could also access by using -1, right? So this is how I could access. For example, this is my small bag and I wanted to access the last element. The last element is Suresh, right? And the first element is also Suresh, and the last element is also Suresh, and the 0th element is Ramesh, right? So basically here -2 becomes the first element, that is 0th element, that is Ramesh. So negative indexing starts from the last element, right? So now there is my bag. In the my bag I wanted to access last element, that was Ramesh and Suresh. If I access -2, then it is true, right? This one. If I wanted to access -3, then is 13.6. If I wanted to access -4, that is 1, and if I wanted to access -5, then it is 5. Okay. Now here one thing to note, if I wanted to access -6, it will give me an error. It will say list index out of range, that the element which is present at -6 was not found. So the array or the list is indexed out of range, right? We cannot access that element because it is not present. Similarly, if I wanted to access the 4th element, Ramesh and Suresh are present, and if I wanted to access the 5th element, so it will give me an error because list index is out of range. We cannot access the 5th element which is not present, right? Okay. Now we come across the list operations. So there are various operations which are by default provided to us, which can only operate on list, right? So these are some of the operations which can only operate on list. First is the length. We wanted to calculate how many elements are present in the list, that we will see. Then there is the append, insert, remove, delete, pop, and then we'll go for slicing, right? So this we'll see one by one. First we'll go for length operation. To calculate the length, that is how many elements are present in a list, we can do it by using the len keyword, len. Right? Now I wanted to know how many elements are present, that in the my bag, that I could do by using the len keyword. So 5 elements are present. Okay. Ideally in this part there are 6, right? 1, 2, 3, 4, 5 and 6. But this element would be treated as 1 because it is a of list data type. So how many types of elements are present, right? This would be treated as one single entity, not double entity, right? So that's why it is showing us 5, not 6, right? Inside this, if you wanted to know how many elements are present inside my small bag, that would be 2 because 2 entities are present, 2 elements are present. right? So this is how we calculate the length of elements which are present in the list. Then the next operation is append. We wanted to add the elements inside the list. We wanted to insert at the end position, right? So that operation is used by using the append method. For example, I wanted to add another entry at the end of the list. I wanted to add Raju at the end of the list. So Raju get added. Now I wanted to check how many elements are present. I can check by using the length operation. 6 elements are present, right? What is the position of Raju? If I wanted to access Raju at the end position, we can retrieve it by using the negative slicing, that is -1, right? Then suppose we wanted to insert an element at a specific position in the list, that we could do it by using the insert method, right? So this is how we could do it. For example, I wanted to add Sonu at the second position, that is after Ram. So this is index 0 and first, right, at the first position. So what I will do is my bag dot insert, right? Okay. Now it is very difficult for one to remember all these uh, functions, and also we wanted to know what parameters does this hold true, right? So in Jupyter notebooks, so uh, there is a method in which we could see what parameters this particular function holds. We do not look for here and there. For example, I type in question mark and enter shift plus tab. I remember, I again repeat it, my bag dot insert, then in the bracket you type question mark, and then after question mark you type in shift plus tab, shift plus tab, right? It will give you the doc type and signature, right? So it says insert an object. If you expand this, right, in this case it is not showing, but in other case you might get also the examples to it, right? We want to look it in the further lectures. So it is saying that insert at what position and the object, right? Suppose I wanted to insert Ramu at first position. So Ram, after Ram, Ramu gets inserted, right? So this is how we could insert an object or a specific entity or a specific element at a specific position, right? So first operation was append. Append is only used to add the element at the end of the list, but insert, you can insert at any specific value. Then we wanted to remove it, right? So remove function removes the first item or the first occurrence from the list whose value is being in the parenthesis, is being given in the parenthesis. For example, we wanted to remove X. So this remove will try to search for black in the list and will remove the first occurrence. So here in this part I wanted to remove my bag dot remove and I wanted to remove Ramu. It will check for Ramu and it gets removed, right? So this is how your remove function will work. Okay. Now, if you wanted to remove a particular element, right, and it is not present, so it will give you an error, that is value error, that is particular element is not present in the list, right. For example, I wanted to remove Ramu again, and it is, as you can see, it is not present in the list, it is already been removed, so it will give me a error, that is particular element is not present in the list, right. So this we have done remove option by the name, by the index name, by the name of the element which is present in the list. But what if we wanted to remove the element by their index position? I wanted to remove the element which is present at the fifth index, or let's suppose second index. So that I wanted to remove by using the del keyword, right. So this del keyword I will use it, and I wanted to remove the last entry, right. So here Raju is the last entry and I wanted to remove it, so that could be removed by using the del keyword. So Raju gets removed, right. Then we can also sort the elements by using its by ascending order, right. So this sorting takes place in the list in place. What do you mean by in place? For example, you have a list, in the list you have some numbers and you wanted to sort that numbers in the ascending order, right. So you could perform it by using a sort method and all the elements get sorted. Similarly, you can do it by the alphabets also, that could be also be done, right. So that for that we need to take another list. For example, I take my list equal to and have some numbers, right. So these are the numbers which you see are not sorted, right, and are not in the ascending order. So if I do a my list, so these numbers get printed. So now I will perform the sort method, right. So this my list gets sorted, right. So there is also another method, that is sorted, we will cover in the upcoming lectures, that is used to sort the elements or the iterables, we call it, by ascending order or by descending order, right. So this that we will cover up in the upcoming lectures. Now we wanted to reverse the operations of a list or reverse the elements present in the list, right. Like that, green, orange and red, we wanted to replace the last element of the index to first and first to last. So this we can do it by using the reverse method, and the reverse also takes reverses the list in place, right. In place means that reverse works on the original list rather than giving back a new list, right. So here in this list I wanted to reverse these elements. So now firstly we have done sorted the elements in the ascending order, and then by doing a dot reverse I have sorted the elements in the descending order. So this operation can be done. Okay. Now we could see the list as a stack. So what is a stack? So stack is basically a list with just two operations, that is push and pop. Push, we need to push a element at the end of the stack, and pop, we need to remove the last element from the stack, right. So The push operation we have already seen, right? So that is, we have seen using the append method. For example, this is a list and we wanted to append 50 at the end of the list. That could be easily done by using the append method, right? We have already seen that. Suppose we wanted to remove the 50, that is element which is present at the end of the list. We can do it, right? We could remove that element by specifying its index place also, and by using the del keyword also, right? But what if you wanted to remove that element, right? Here in this stack.pop we are retrieving that element and the element is also getting removed, but in that operation, in the remove or either in delete, the elements only gets deleted, but we are not able to retrieve that element. But by using pop method we are going to retrieve that element, right? If you wanted to know what is present at the end, right? So that could be done by using the stack.pop or list.pop method, right? So this is my list and I wanted to do a pop. What it will give me? It will retrieve me the last element, and this particular elements will also get deleted from the list. So this is how your list as a stack works, right? Now we'll cover the another topic, that is list slicing, right? So what is list slicing? So this is your list, right? And I wanted only the elements starting from 0 to only retrieve the first 3 elements, that is starting from 0 to 2, right? So only the 3 elements I want. So this I wanted to do it. So how I can do it? By using the slicing method. So how does slicing method works? So this is my list. You specify the start, then you specify the colon, and you specify the end. So what does start and end means? Start means your starting index and end means your ending index. So you wanted to retrieve the elements from first to 3. So you specify the start index, that is 0. Here I specify the 0. And you want here till end, that is third. If you want till end, you don't specify end, you specify this end plus 1, right? Because end will not work on the this operation, it will work till this operation. It is always the end minus 1, that is one index less than the what you have specified in the index in end, right? So here I will specify 3. If I specify 3, up till 68 elements will be retrieved, and this slicing works this way. If I specify 2, only the 0 and 1, it starts from 0 and ends with 2, but not including 2. 2 element present at 2 second index or the second position will not be included in this slicing method. So this is how you perform the slicing, right? So this is your first method, right? Then so the nomenclature of the slicing is that you specify your start, then colon, then end, right? If you don't specify your start and only end, it takes by default 0, right? Will take default 0, right? If you don't specify, right? Similarly, if you don't specify the end, right? Now I have not specified the end, so it will go up till the end of the loop, up till starting from 2, 0, 1, 2 and go up till the end. So it started from 2 and gone up till the end, right? Got it? So this is how your slicing works. And if you don't specify anything, you don't specify either the start index or the end index, so it will by default takes from 0 till the end, right? So this is how your slicing works. So here in this part there are 4 examples which are shown. Indexing starts from 0 till the end, so 0 up till end, so all the elements get printed. Indexing starts from 0 and will go up till 4, but 4 is not included, it will go up till only the third index, that is 0, 1, 2 and 3, right? Now here we can separate it by using start and end index, that it starts from 1 and go up till 3, but 3 is not included, only 2 is included. And while we don't specify anything, it will take all the elements. So this is how your slicing will work, right? Okay. Now, so in this part we have seen the append method, right? We have seen the sort method, reverse method, then delete keyword, remove and insert, right? So these are the methods which we have used, right? Now can I change the value which is present at the index 0, right? First let us check what is present in my list. This is my list, right? So in this my list some elements are present. For example, I wanted to change the element which is present at index 0 to some other value. I simply can give the assignment operator and can change the value to any value which I feel like, that is of Python data type, right? Now this value has been replaced by RAM because we have changed it. So this change is known as mutability, right? So we are trying to change a value which is present at a particular index, right? So these were the elements of the list and we wanted to change it, we have changed it. So this is why it says lists are mutable, right? We can change its value, we can modify its value, we can add its value, we can remove it. So this is how lists are mutable. If someone asks you why lists are mutable, so we can change the value which is present at the index position. So that is why lists are mutable, right? Now there is another concept in lists, that is shallow copying and deep copying. So let us try to understand that, right? For example, this is your list, say my list 1. So there are some elements which are present in list, Ram, Sham, or I'll say 12, right? Got it? So this is list which my list 1, sorry, right? So 3 elements are present, right? Now what I do is I create another empty list, right? So I created another variable and I put all these elements inside this variable, that is my list 2, right? And now I'll check what is present in my list 2. Same, in my list 1 also Ram, Sham and 12 are present. In my list 2 Ram, Sham and 12 are present, right? But they are both separate lists because these variables are different, right? Now suppose I modify the element of list 1 or append or insert a element to list 1. For example, I wanted to append element in list 1. Let's add Raju to list 1. Now Raju gets added to list 1, right? But we haven't modified or we haven't changed anything to list 2. That we all agree, because we are doing the operation on only on the list 1. Let us try to see what is present in list 2. Now as you can see that list 2 also gets modified, but we haven't done anything on list 2, but still it got modified. So what went wrong here? I was only trying to change the position or change the values present in the list 1, but list 2 also got modified. So what has happened here? Basically what has happened, these when we do a assignment operator in case of the list, so it is basically we are assigning a name to it. We are not creating a new list. So let us visualize this, and which are able to help us understand better, right? We'll see what actually went wrong here and how we could try to solve it. Right? So this was my list. So I just copy all the elements to my list so that we could save some time. Okay, so these are the elements which are present in my list, right? So now what I do is my list 2 equal to my list 1, right? So this is perfectly fine. Then what we did is my list 1 dot append, right, Raju, right? Then we are trying to see what is present in my list and what is present in print my list and print my list 2, right? So this we are trying to see. So let us check. Okay, now at the first iteration or the execution of the first line, so my list got created. So this is your global frame in which my list is pointing to some of the elements of the list, as we have already seen that list is behaving as a stack operation. So at the 0th position Ram gets inserted, at first Sham, and at the end of the list 12 is there. So this is my list which is pointing to these values. Then at the second point, at the second number, we are just pointing or we are just converting this my list into my list 2. So let's see. So what had happened is this my list is also referring to the same list. It has not created a copy of it. We are only referring. So this is basically an aliasis, a different name. So my list is also this and my list 2 is also pointing to the same objects, right? Now if I append into my list, we are basically appending Raju to my list 1 and my list 2. So which is basically the same. So there is no difference, right? So when we printed it, so it came out to be same, right? But here, instead of doing this thing, if I do a copy, my list 1 dot copy, then we are trying to create a new list. So let us see how this happens. My list got created. There is another my list 2 that got created, which is the exact copy of these elements. And then in the third part, we are trying to append Raju in the my list 1. That got inserted, but there is no such change in my list 2 because it is in another copy. So they are basically residing in the memory at different locations, different pointer locations. So this location is different and this location is different, right? So that's why change in first list does not affect the change in the second list. Then we are printing the mylist1 and mylist2. So right, so this is how your shallow copying and deep copying concepts work. So this is basically called a deep copying, right? And the first example which I given you, that was shallow copying. So we are trying to have the list, right? So it is basically pointing to the same list, right? So this is how list, shallow copying and deep copying works, right? Okay. Okay, so now we'll cover to the programs. Okay, so now there is a program which I wanted you guys to first try it out, and in the separate lecture we will have the solutions to these programs. So first program is that even and odd. We wanted to store even numbers and odd numbers in a separate list till 50. So how this can be done? This could be easily done by iterating through a loop, right? Right. So how we can iterate through a loop for number in range of 0 to 10, right? So we have print number. So 0 to 10 we have printed all the numbers. Now here, instead of printing, we could write a logic. If number is divisible by 2, right, we could create a new list, right, and append the values which are divisible by 2 only. Else we could have in a odd list. So this is 2 list, we could have even dot append, and here we could have odd dot append. So this is how your first program will work, right? Then there is a popular program known as Armstrong, right? So Armstrong is a number that is equal to the sum of cubes of its digits. For example, let us take 153, right? So 153, right? If I try to take the cube of 1, then 5 cube 3 and 3 cube 3, and I have wanted to add all these numbers. So it comes out to 153. So that number is called an Armstrong. If we separate out all the numbers of the particular 2-digit number or 3-digit number, right, and cube that numbers and take the sum. First we need to cube, then take the sum, and then after that we wanted to compare whether this number was equal to the original number or not. If it is, then it is an Armstrong number, right? So these are the sum of the Armstrong numbers we need to find out. 153 is Armstrong, 370 is also Armstrong, 371 and 407, right? So this you need to try. So first the logic is that you take a loop or a range function in which you take from 0 to 1000, then you take a number, right, then you divide your number, right, and then after dividing your number, right, taking the remainder, and then after you take the cube root and add all the cube roots of that number, of a 3-digit number or 2-digit number, and then check whether the number obtained is equal to the original number or not. If it is, then it is an Armstrong, else it is not, right? Then we'll see palindrome. What is a palindrome? Right? For example, if we reverse, for example, we take a string that is Nitin, right? If you reverse Nitin, so all the elements will be Nitin only. This is a palindrome, right? Right. So we wanted to check whether the reverse of a string is the original string or not, right? And how many palindromes we could obtain it by using this part. Whether we wanted to, like ITI is also a palindrome, right? Because the reverse of ITI is also a original number compared to original number, right? So this will you do it, and then in the next part we will look to their solutions, right? Thanks for watching. Thank you guys.